Hello. See, today this is the third class. So, up to now we discussed in kinematics. So, we are giving online live classes for you at free of cost. At free of cost. So, if you interested, you can subscribe and you can get notification for this. Okay. Next, if anybody interest, if you like this video, if you want to share some other, you can share the video. This is a live class. So up to now we discussed kinematics. So in kinematics, see, up to now we discussed rest. Okay. Next, motion. These two are relative. Is it? Next, rest, motion, relative. Next, we discussed distance. Is it visible? If it is visible, is it audible? You can message me in chat box. Distance, displacement. Displacement. So these are the quantities, physical quantities, that means distance, displacement. Up to now we discussed in kinematics. Then speed, velocity. Is it or not? Yes. Average velocity. So next, average speed. See, like this we discussed up to these concepts. So especially I did not mention average speed. So it is same like the formula we can use for this average speed also. Where the direction we consider, then we use average velocity. When there is no direction, use average speed. So I will give one more uh, important formula for you. After completion of your intermediate, you are going to write MSET or IITG mains. So this is a foundation for you. I am giving basics for you. Just listen. If you have any doubt, you can message me. Then in YouTube also, I will upload this after Smart Academy. See, if you type in Smart Academy for Physics, Smart Academy for Physics in search box in YouTube, you will get my channel. So there you will get my video. After completion of this class, automatically generate the live class video also generate. I will upload there public. So if you have any doubt after watching this one, if you are not getting, if it is some 1 or 2 minutes it is not clear also, you can watch there also in my YouTube channel, Smart Academy for Physics. You can, if you type, you will get this symbol. Okay. So I will start to some little bit one more problem here. See, this is up to now we discussed these concepts. See here, a body or a particle, a body or a particle, a particle or a body starts from A, reached B with velocity v1, then comes back. See, travel from A to B with v1 velocity, then it comes back B to A with v2 velocity. So what is the situation here? This is one of repeated, see, different situation here. A particle or a body starts from A and reached B with v1 velocity. Then from B, it comes back, return with v2 velocity. Then for average, see, you have to write like this: a body starts from A and reached B with the velocity v1, with velocity v1. Then it comes back B to A with velocity v2. Then find average velocity. Find average velocity. This is a question. So you write like this only. This is also important formula for you. See, body or any particle, a car, whatever it is, it travel from A to B with v1 velocity, then B to A with v2 velocity. Same distance covered in both cases, because A to B the distance will fix, that is constant distance. But initially to travel A to B with v1 velocity, then A to B travel with v1 velocity, then comes back with the v2 velocity, then average velocity of that particle or body. So for this one, 2v1 v2 by v1 plus v2. 2v1 v2 by v1 plus v2. This is the average velocity for this case. I am giving direct formula for you. What is the case here? A body starts from A, reached B, then comes back to B to A. A to B, then B to A. So what happened here? With v1 velocity, it went with v1 and comes back with v2. What is the average velocity here? 2v1 v2 by v1 plus v2. v1 plus v2. So based on this information, I am going to give one problem for you. Okay. If you copy, you can message me yes. Come on. But it is okay, message me first. Yes. Now I will give problem. See, a body starts from A and reached B with velocity and giving here 5 kilometer per hour. It comes back B to A with velocity 10 kilometer per hour. Find its average velocity. This is a question. This is the problem. Do it. First, what is the formula here? Average velocity equal to 2v1 into v2 by v1 plus v2. Is it? Okay. What are the magnitudes? 5. Next, 10 by 5 plus 10. Is it? 2 5s are 10, 10 10s are 100 by 10 plus 5 15, 5 20, 5 3s are, you will get 20 by 3 kilometer per hour. This is average speed, average velocity in this situation. This is very important. Simple. It travel A to B, then comes back B to A with different velocities. The displacement or distance is fixed. For this one, what is the average velocity? We have to use this formula. 2v1 V2 by V1 plus V2. Okay, right? Is it okay? Then message me yes or no. Then I will go for one more. Okay or not? Message me, yaar. Simply watching, I will not get any information from you. If you put yes or no, is it okay? Did you understand this problem? Okay, right. Okay, now next, see one more. So average velocity we finished. Instantaneous velocity. This is also there. Instantaneous velocity. Instantaneous velocity. What it means? Instantaneous velocity. Simple. See, a particle or a body starts from A and reached B. Starts from A and reached B. In our general, for example, I am traveling from Jaichal to Karimnagar. Is it? Well known, see the A to B is boring. Jaichal to Karimnagar. What? We are traveling. See, in the covering the distance, that is Jaichal to Karimnagar. Otherwise, while in the traveling, velocity at particular instant. See, particular point. For example, we are traveling from Jaichal to Karimnagar. See, I want at Kondagattu, what is the velocity? See, what I want at particular instant, at particular point, at particular time. See, we travel Jaichal to Karimnagar, for example, 40 minutes we travel. See, I want at 38th minute. What is the velocity? That is nothing but instantaneous velocity. That is nothing but instantaneous velocity. That means you can write the definition. Simple, don't write much. Velocity at particular instant. Particular instant of time. A particular time, a particular point there. We can say instantaneous velocity. Okay. Is it okay? I think simple. Particular 40 minutes we travel. I want only 38th minute. What is the velocity? If it is have some value, we will get that value is equal to instantaneous velocity. Velocity at particular instant of time. That is nothing but instantaneous velocity. Instantaneous velocity. See, we are discussing distance, displacement, velocity, speed. Velocity, in velocity we discussed what is the velocity. Total displacement by total time. Average total displacement by total time. Here it is instantaneous velocity. One more concept also is there. Okay. One more, uniform velocity. Uniform velocity. Do you know what is uniform velocity? Can you message me? Can you message me? I think you are the children of studying 9th or 8th class. So regularly what you will wear? ఏం వేసుకుంటారు రెగ్యులర్గా? What you will wear? Uniform. Uniform means every child will come in single dress. That is uniformity. For uniformity purpose only, you will come in a common dress. That is uniform. Uniform means should be same. velocity. Velocity should be same. What it is? Jaityal to Karimnagar while traveling, the velocity at a particular point, at velocity this point, at velocity this point. For example, we are traveling here 20 kilometer per at point A, point B, point C, point D. 20 kilometer per hour velocity at point A. Then 20 kilometer per hour at point B. 20 kilometer per hour at point C. 20 kilometer per hour at point D. What it means? Throughout the journey, that means from Jaityal to Karimnagar, if you want to check at any point, if you want to check మనం చెక్ చేయాలనుకుంటే at any point the velocity, if it is same, then the body is in uniform motion, otherwise it is moving with uniform velocity. Simple. What is the question here? What is uniform velocity? See, what I am discussing, while traveling a body, otherwise a body traveling in throughout the journey, if you want to check any particular point at a particular instant throughout the journey, if the value if it is same value you will get, then the journey is moving with the uniform velocity. So for this one, you write simple uniform velocity throughout the journey of a body if it has same velocity. Then we can say the body has uniform velocity. For this one, you just draw this picture. Jaityal, Karimnagar. See here, this point, this is the initial point, this is the final point. So I am checking here particular point A, point B, point C, point D. For example, here 30 kilometer per hour. It should get at point D also 30 kilometer per hour. 30 kilometer per hour. If you want to check it here also, we should get that value only. Then only we can say it is uniform velocity. It is moving with uniform velocity. That is, uniform means uniform throughout the journey, uniform same velocity if it is moving. So these are the types of velocities. First, what is velocity? I am discussing. See, first you write this. One. If you complete this one, if you copy it, then message me okay or yes. Then I will say one more. Okay, right. See, I want to compare two velocities here. See, we discussed velocity average, velocity instantaneous, velocity uniform, velocity total displacement by total time. This is also total displacement, total instantaneous at particular velocity at particular instant of time. Uniform velocity throughout the journey, the velocity should be same. These are the, now we are comparing these and these three. See, throughout the journey. See, for example, you are watching my video. Okay, Balu is there. Balu started at Jaityal, reached Karimnagar on a car. The car. See, the car is moving. He is in the car. The car is moving with 20 kilometer per hour. With the uniform velocity. That means its starting point, initial, final. Initial, final. Initial point, final point. He is moving. He is traveling with 20 kilometer per hour throughout the journey. Then we can say the ball is moving with uniform velocity. Uniform velocity means 20 kilometer per hour. Average velocity will be also same. Average velocity also same. So for this situation, if a body is moving with uniform velocity, the average velocity also is same magnitude, same how much it is, how much the value of uniform velocity. So uniform velocity, if it is moving with uniform velocity, same value will get average velocity. Both are same. This is the one point I want to give to you. So what is that point? Simple. If, right, this is also important point. If a body is moving with uniform velocity, the average velocity and instantaneous velocity are same. Average velocity value, instantaneous velocity value, uniform velocity, both are same. Three values should be same. At instantaneous velocity means a particular point, same value you will get. If average value you will get, that is also same. So this is the one point. If a body is moving with uniform velocity, then if it is moving, the average velocity and instantaneous velocity are same. Instantaneous and average velocity are same. Okay, this is about velocities. So I want to complete the velocity concept. Some problems are there, I will give after that. First theory I will complete. Okay. Now new concept here. See, for this new concept, see, while traveling, so ball is traveling from Jaichal to Karimnagar in a car. He started with starting. Initial only you will get 100 km per hour. Will you get? No, you will not get 100 km per hour. Initial, it's starting. So for example, you are now starting to Karimnagar. You are moving in this direction. Okay. Now, initially your velocity, initial means car not yet started. You did not start car. You haven't start car. You haven't started car. Start చేయలేదు. The velocity is equal to 0. After some times, you will increase the velocity. If you are on the bike, you will increase acceleration. If you are in the car, you will accelerate. You will press the accelerator. So what happens after some times? We will become to 20 km per hour. Then you will become 30 km per hour. Then you will become, your velocity will become 40 km per hour. Finally, you want to stop at Karimnagar. Is it? After reaching your reaching point, that means your destination, if you reach, you will stop the car. Finally, what happens? The equal to here also 0. You started with 0 velocity. You started with 0 km per hour. You are increased your velocity. Finally, you stopped the car. What happens here? The velocity starts 0, 0, increased, finally stopped. Finally, see, it starts with 0, slowly. Here, initially you don't have any velocity. You increase your velocity, increased, finally stop. What happened? Stop. So what you are observing here? The velocity is changing while traveling from Jaityal to Karimnagar. The velocity is changing. The velocity changing means velocity is a vector quantity. Velocity is a vector quantity. Vector means already given. Vector is nothing but it has magnitude and direction. So while traveling from Jaityal to Karimnagar, you might have changed your direction. You might have changed your magnitude. That means you are increased 20 to 30, 30 to 40 like that. You are changing your magnitude value. You might be changing your direction also. If there is changing in two, that is in magnitude. If there is change in magnitude, otherwise if there is change in direction also, your velocity change. So here the magnitude is changing. So what happens? See what I am saying here. There is initially v equal 0 to, we change it to v equal to 30. So for this one, see how much time it will take. That is also time. Time also important factor here. See, the car starts with 0 kilometer per hour and gain 30 kilometer per hour in time, in some time. That means 5 seconds, 5 minutes, like that. So there is change in velocity, change in time. There is change in velocity in 5 minutes. There is change in velocity in 2 minutes. There is change in velocity in 10 minutes. So what is happening here? There is change in velocity in change in time. So for this concept, I am introducing one more physical quantity in physics. Very, very, very important factor. Important concept, that is acceleration. Acceleration. What is this? Acceleration. We can denote with small a. Small a. So what I introduced for to you, acceleration. So generally bike has two. See, this is a bike. Means this is a handles. This is also handles. So while driving, you are increasing accelerator right side. See, for example, I am traveling the bike. If I want to increase the speed of the bike, I want to increase accelerate right side. That acceleration, I want to increase acceleration, then I will get more velocity. So what happened? That word only I introduced you. Acceleration. What is happening here? If we increase acceleration, you will get more velocity. So acceleration we are denoting with a. We are denoting with small a. That is equal to change in velocity by change in time. This is simple concept. Regularly you are observing. If you take bus, accelerator is there. If you press the accelerator, you will get speed. If you are driving bike, if you increase your acceleration, it will get more velocity. There is accurate, it will get more velocity. So for this formula, acceleration is nothing but change in velocity by change in time. Change in velocity by change in time. Otherwise, simply also you can do velocity by time. Velocity by time. So you first don't write these things. I introduced one physical quantity here for you, that is acceleration. You keep heading acceleration, right bracket in small a, that is a equal to, write this formula. Okay, come on, copy it. Very, very, very important concept in physics, acceleration. Okay, if you copy it, you message me yes. Okay, now, so for unit, what are the units for acceleration? Units. How do we calculate units for this physical quantity? See, small a, velocity by time. Velocity by time. See, We can define. How do we define first? See, rate of acceleration, you can write definition. So already written this one. The rate of change of velocity. Rate of change of velocity is known as acceleration. That's it. You write simple definition. The rate of change of velocity. Rate of change of velocity. That is acceleration. So, acceleration A equal to velocity by time. Is it okay? This one. I will explain what is the rate of change of. Okay, now velocity units. Already I discussed. Velocity is nothing but meter per second. Here also time is there. This is in numerator. In denominator, yes, that is also second. What happens? In numerator, a meter per second, this is one fraction. S by 1, this is also one fraction. M by S into 1 by S. M into 1, M. S into S, S square. So what is the unit of acceleration? In M case units, meter per second square. Meter per second square. So unit meter per second square in MKS system. In MKS system. Centimeter per second square in CGS system. Okay, write these things. So I introduced now acceleration concept. What is acceleration? The rate of change of velocity. The rate of change of velocity. So acceleration equal velocity by time. So for velocity the units meter per second, for time seconds. So if you convert, if you do some mathematics, you will get finally the units meter per second square. So unit is meter per second in MK system, centimeter per second square in CGS system. Okay, okay. See here the word. This is very important. Rate, 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 rate. Rate means in 1 second. In 1 second, how much velocity change? In 1 second, how much the velocity change of velocity? That is, we can call it is a rate. Rate means we have to measure change in velocity in 1 second, in unit second. So acceleration is nothing but change in velocity by time. Okay, so change in velocity time per second. You take in denominator should be 1 second you have to take while define the acceleration. If you want to define any physical quantity, you can define like this. In 1 second, how much change in velocity? That is nothing but acceleration. That is only rate of change of velocity in 1 second. Rate of change of velocity in unit second. Rate of change of velocity in 1 second. That is nothing but acceleration. That is nothing but acceleration. Okay. Okay, right. Okay, next. Okay. Acceleration over. Then, for example, A equal to change in velocity by change in time. So this is in the words in English terminology. So, for example, a body starts with u velocity. Starts with I don't want to write there. See this. Here point A, the body has u velocity initial. Finally, it reached B, the velocity gains change to v. So what happens here? The velocity u2 change to v. The body has initial, it has velocity u meter per second. Finally change to v meter per second. There is change, is there change or not? Is there change or not? Yes. U change it to V. U meter per second change it to V meter per second. In how much time? Initially time is T1. Final there after reaching the time is T2. T1 seconds to T2 seconds. That means if it started 5 hours 15 minutes, then it reached 5 hours 40 minutes. How much time it has traveled? 15 minutes for 25 minutes travel, like that. For example, I am giving this time. So it started at T1 time and reached T2 time. It started with U velocity, finally it reached with V velocity. You just draw this one. First you draw A, point B started with U velocity and reached with V velocity. So for this one, acceleration for this motion. Change in velocity, final it reached V minus, change means difference. Change is nothing but this change means how much difference. T2, final time T2 minus T1. This is acceleration formula. I think you understand well. Nothing is there. It started with U meter per second and reached V meter per second. Reached the destination point with V meter per second. It starts at T1 time and reached with T2 time. So acceleration equal to change in velocity by change in time. So U change it to V, T1 change it to T2. That means V minus final velocity minus initial velocity, final time minus initial time. V minus U by T2 minus T1. V minus U by T2 minus T1. Okay. Here you just write, because after some days you will get what is V, what is U. That's why I am giving here U equal to initial velocity, B equal to final velocity, T1 initial time, T2 final time. These are you have to write. Is it visible? Initial velocity, final velocity, initial time, final time. Nothing is there. Acceleration equal to V minus U by T2 minus T1. T2 minus T1. Is it okay? Okay. I will give one problem based on this. Okay, I am writing one problem here. A body starts with 20 kilometer per hour. Otherwise, why do we use kilometer per hour? 20 meter per second. Starts with 20 meter per second and reached a point with 30 meter per second in 10 seconds. In 10 seconds, find its acceleration. Write the question. First write the question. First, For this one, I will give the solution. I will give the solution. Okay, solution. For this one, see, a body starts with 20 meter per second. For example, this is one body. U equal to 20 meter per second. It is move and reached here 30 meter per second. Initial velocity we can denote with the U. Final velocity is 30 meter per second. The time taken 10 seconds. This is time. So the change in time is 10 seconds. Initial velocity 20 meter per second. Final velocity will be 30 meter per second. So then acceleration equal to V minus U by T2 minus T1. V equal to 30 minus 20 by T2 minus T1 is the difference in time, that is equal to 10 seconds. So 10 by 10 you will get 1 meter per second square. The acceleration of the body is 1 meter per second square. Okay, copy it. I will give one more question, then you will do. Okay. Okay. Now I'm giving one more problem to you. You can do easily. Nothing is there in this problem. How much velocity it is starting? It is increased to how much, to which velocity it is goes to increase? Goes to increase. Which velocity is starting? 20 meter per second. Finally it reached with 30 meter per second. How much time it is taken? 10 seconds. So acceleration is nothing but V minus U by T2 minus T1. V is final velocity here. U is initial velocity. How much time taken to increase 20 to 30? 10 seconds. Just use abstract sum. Do it. Next. I'm changing here. This is 30. Here it is 50 in 10 seconds. Do it fast. Do it fast. Fast. Come on. Here 30 meter per second, then change it to 50 meter per second. Time taken 10 seconds. U equal to 30 meter per second. This is nothing but V equal to 50 meter per second. 50 meter per second. Time equal to, that is change in time, that is equal to 10 seconds. For this one, find acceleration. A equal to V minus U by time. T equal to V equal to 50 minus 30, that is change in time. T2 minus T1 is nothing but I written here only one thing, that is equal to 10. 20 by 10, you will get 2 meter per second square. 2 meter per second square. Very good, Balu. Very nice. Okay. This is acceleration. Now okay, I will introduce one more. See what I will introduce here. A bike. See, this is one bike. See, this is one bike. It starts with 30 kilometer per hour, then it increases to 50 kilometer per hour. Is it? it starts with 30 km per hour, then increase to that velocity of that car, that bike, 50 km per hour. So there is change in velocity, that is 50 minus 30 equal to positive value. You are getting positive 20 km per hour increased in time 10 seconds or 5 times. So acceleration, if you calculate acceleration, for example 5 seconds is taken, 50 minus 30, 50 minus 30, simply it starts with 30 km per hour, then goes to increase it to 50 km per hour in time 5 seconds. So acceleration of this ball, this is 5 seconds, 50 minus 30 by 5 seconds, 20 by 5, that is 4 meter per second square. 4 meter per second square. Okay. See, we are getting here positive value, that is plus 4 meter per second square. This is a positive acceleration. I will give one more example. That means 50, it starts with 50 kilometer per hour. 50 kilometer per hour. It starts with 50 kilometer per hour. After some time, the velocity decreases to 30 kilometer per hour in 5 seconds. 5 seconds. Acceleration for this 30 minus 50, not 50 minus 30. Final velocity is v. U equal 50. Here U equal 30. V equals 50. 30 minus 50 by 5 minus 20 by 5, you will get minus 4 meter per second square. So in two cases, this is case 1, this is case 2. See, this is case 1, this will be case 2. Case 1, case 2 we have here. In first case you got positive acceleration. In second case you are getting you got negative acceleration. If the body is moving with positive acceleration, if a car, if a train, if a bus, if a aeroplane, if a body, whatever it is moving with positive acceleration, you can say the body is in accelerated motion. The body is in accelerated motion. Otherwise, if any body has negative acceleration, we can say the body is in decelerated motion. Accelerated motion, decelerated motion. See, the body is getting positive acceleration while traveling. It has positive acceleration. Then we can say that the body is accelerated body. If the body has negative acceleration, we can say decelerated body. So negative acceleration is nothing but deceleration. Negative acceleration is nothing but deceleration. This sentence also you have to write. Simple, regular, what we are observing in regular daily activities, that is only physics. So here simple, write a point. If a body has positive acceleration, we can say the body is in accelerated motion. Otherwise, the first one, positive acceleration unte accelerated motion lo unnadu. We can say if a body has negative acceleration, we can say the body is in decelerated motion. So negative acceleration, we can say that is decelerated motion. Positive, if the body has positive acceleration, we can say accelerated motion. That means A equal to positive, here A equal to negative. Next, one more point, negative acceleration is called deceleration, okay. Acceleration, deceleration. So these are the regarding to what acceleration concepts. So many are there. In every motion we have to calculate acceleration. I am not giving here examples of accelerations. You may get after classes, that is linear motion, like circular motion, simple harmonic motion. You may get different situations, different acceleration values. So different cases will be there. For me, I want to give to you at this level, at 8th 9th class. This information is enough for you, okay. Just copy it. If you copy, just message me yes. Okay, message me yes. If you complete, message me yes first. What? Okay, now I want to give average acceleration. I want to give one more, average acceleration. Average acceleration. For this formula I am giving. So how do we calculate acceleration? Average acceleration. So here if, write this one first, don't write this. If a particle travels with acceleration a1, with a1 acceleration for time t1, a1 acceleration, it is traveling for time t1, comma, with a2 acceleration with t2 time, then a3 acceleration with t3 time. Find its average acceleration. This is one important formula. Okay, see what I am discussing now. Average acceleration in this situation. What is the situation? If a body travels with acceleration a1 for time t1, for acceleration a2 for time t2, next a3 acceleration with t3 time, means for t3 time. Find its average acceleration. For this one, average acceleration equal to a1 into t1, a1 into t1, a2 into t2, a3 into t3 by t1 plus t2 plus t3. This is average acceleration. This is average acceleration for this situation. A body or a car, a particle travels with a1 acceleration for t1 time, a2 acceleration for t2 time, a3 acceleration for t3 time, a1 into t. Acceleration time, what you are getting velocity, you will get velocity by nothing but velocity by time. First velocity, second velocity, third velocity, total velocity by total time. That is nothing but change in velocity by change in, that is nothing but acceleration. A1 T1 plus A2 T2 plus A3 T3 by T1 plus T2 plus T3. Simple. Same like average velocity, displacement, velocity. S1 plus S2 plus S3 by T1 plus T2 plus T3, like that. Okay, just copy it. I will give some problems to you, homework for you. Okay, copy it. If you copy, just message me yes, 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 yes. Come on, fast. Come on. Okay. Yes, okay, right. I will give problems to you. I will give picture only. You can, I don't want to write first one. Here, u equal to 20 meter per second, v equal to 30 meter per second, t equal to 5 seconds. Find a, how much? Next, one more. U equal to 0 meter per second, v equal to 50 meter per second, time equal to 50 seconds. Find a. Then one more. U equal to 50 meter per second, v equal to 20 meter per second, t equal to 30 seconds. Find a acceleration. Okay, next fourth one. Here, see, travel like this. A1 equal to 2 meter per second square, t1 time equal to 2 seconds. Then see, up to A to B, it travel with A1 acceleration for t1 time. Then A2 3 meter per second square, t2 equal to 3 seconds. Up to this period, this so for example P2C, A2 acceleration with for t3 t2 seconds. Next, A3 equal to 4 meter per second square, t3 equal to 4 seconds. Finally it ends with journey. So find average acceleration. A equal to what? So do these four problems. If you have any doubt, if you want to go back this video, if you want to check this video, you type in YouTube. First you subscribe my channel, Smart Academy for Physics. Then you will get in that, go for videos, live videos. You will get this video after 10 minutes. You will get. If you want check back, you will. If you want copy the problems, if you want to clarify any doubt what I explained in this video, you can go through the video. Okay, thank you. If you finish this one, bye bye, message me bye bye. If you have any doubt also, you can message me in the chat box. Come on, Balu. Okay.